Me too, but I'm looking for my marker. Where's my marker?
Too much trouble with the crackers. What's going on, Dylan? That's so extra, man.
What is he doing?
Oh, I forgot.
We keep you young. Alright, here we go. Step by step, asking people I don't normally get to hear from. Eileen, how'd you start number 6?
Set the limit to of a sub m.
Okay.
So limit to infinity set. Is it not right?
That's the block. Okay, so limit as n goes to infinity of a sub n.
Yeah.
Okay. What happened?
If you take the limit of it, you see that the degrees are the same and the coefficients are 1 over 1. And since it doesn't equal 0, it diverges by the M-term test.
Since the limit as n goes to infinity of a sub n is equal to 1, which does not equal 0, I'm just saying it louder so the rest of you guys can hear, then the series diverges by the, what's the only other approved name for this test?
Divergence.
Good. The nth term test or divergence test. It is not called the limit test. You guys agree?
Yeah.
Dun 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 dun. Number 7.
Unfold.
Number 7. Start us off. Ooh, who's something else I don't usually hear from? Ethan, start us off.
Set the
Dylan, let Ethan do it.
set the limit to infinity.
Okay.
Then equals 1 over n.
Okay.
So it's decreasing.
Oh, careful though. What does the limit equal?
Infinity.
No. Dylan, help out. Oh, go ahead, Ethan. What's it equal?
0.
Do you know why?
Because it's bigger than
The bottom.
bottom wings.
Yeah, there you go. There you go. So then the limit equals 0. So I can say since the limit as n goes to infinity of 1 over n is equal to 0. And then Tom, keep going. What's next?
And 1 over n is the
Uh-huh.
yeah.
Good, good, good.
And use the what's that called?
Absolute value.
Yeah, absolute value.
Good.
And it's I think it's diverged.
Good, good, good.
It has.
So we're doing the absolute value.
P30.
Good, good, good. Okay. So the series of the absolute value diverges, and then you said P series, right, Tom?
Yeah.
Good. Since P equals 1, is that okay?
Yeah.
Then Dylan, finish us off. What's the conclusion?
So the series is divergent.
I somewhat agree. The absolute value series is divergent, but by the alternating series test. That would be the by. If the limit as n goes to 0, a sub n, sorry, to infinity, of a sub n is 0, and if the terms are decreasing, even if the absolute value diverges, what's the special term for the alternating series itself? It's a struggle, right? The absolute value one diverges. But the alternating series converges because these two conditions are met. So I say converges, but I need to add on, because of the divergent absolute value, that it's what kind of convergence? Alan's helping. Conditional convergence. No, it's okay. Does that make sense? So it converges, the alternating series converges, because this and this are true. But when I went to go look here, I say, oh, you know what, it converges, but only because, conditionally, it only converges because of the -1, not because of the n. but it converges because of the negative one. Without that, it would diverge. So this is just a special adjective to say by Cameron, thank you. It converges, yes, but only because of the alternator. Does that make sense? So it converges, but not absolutely, conditionally. Kyle?
So this is a technical question.
Yeah, go ahead.
The absolute convergence and the conditional convergence is all labeled under alternative series test, right?
The conditional and absolute convergence are only for alternating series. I wouldn't say it's under the test, because the test says, check, check, he converges, done. That's what the test says.
Okay.
But we're adding in the extra condition and saying, okay, test, check, check, converges, but then we say, hey, you know what? We won't just say converges, we'll say how it converges, and so we'll go one step further beyond the test and say it's conditionally convergent.
Okay.
But we're not gonna like list all that and be like, oh, hey, by definition, and,
Okay.
no.
So the AP test people will be commenting conditional and convergent on their FRQ.
They expect you to be able to answer if they ask for absolute or conditional. But if you see this, say, in a multiple choice question, this would probably be one in a long list, not long, but 3 or 4 or 5, a list of 3 or 4 or 5 different series that you're trying to figure out which of the following converge. So at that point, you wouldn't really care about conditional or absolute, unless you can check the absolute faster than you would the other two conditions. But otherwise, you just care whether or not it converges, and the absolute conditional has no bearing.
Okay.
Is there another question? Okay, let's go to our notes. Because there was one example I don't think we finished yesterday. I think we started it, didn't finish it. I did just turn the temperature up. The air should turn off soon. Ironically, it's not actually turned up that high. I don't think we finished number 5 in our notes. I don't think we finished number 5 in our notes, so let's go there. Let's pick up where we left off on number 5. This homework is due tomorrow, just quick heads up. But for those of you that have worked on the homework, you got to something where it would start talking about error. That's what we need to finish today. But right now, number 5. With the work that you have done in your groups, go ahead and finish it off for me. We got stuck somewhere because it was about to take a little bit of time and we didn't have that time.
Oh, you the limit. You can do it. I was talking about integral. You want to integrate that?
Yeah, you said you can do the negative 1/2. Find the result of way.
You take out the negative 1 part, so then you would just have 1 over.
So I think the limit first is a lot easier.
Finish it!
One over square root. I think that means that limit, that limit is that is over 1 over square root n equals 1. That means what happens to one happens to the other, so 1 over square root n never happens to the other equals negative. Because that's bigger. No, because of the, no, that's
smaller, because there's a thingy inside. Oh wait, no, just move.
no, it's 1 over square root n. That's the comparison.
No, what he's asking is like, which is
No, they're the same. They're the same. They're the same.
the graphs.
In terms of strength, they're the same. Because the limit's going to be that's not infinity. That would indicate one's stronger than the other. But since it's like a constant greater than 0, that means it's the same rate.
No, because the strength is the same.
Oh, that's unfortunate.
Wow.
So
I mean, if you're looking at basketball.
That's
Ignore that and think about that.
that is conditionally convergent. You understand the comparison?
Wait, what's the other one?
Direct versus.
Yeah, what's the difference between direct and oh, is it when you're given something?
Direct is basically you make it bigger one or smaller.
Of the actual series.
Do you guys agree with my limit comparison test saying that the absolute value diverges?
Got it.
Yes.
Also, you can do it.
So therefore, I can say, since the limit is 0, check, the terms are decreasing, check, the absolute value is divergent, then our original series is what?
Conditionally convergent.
Good. Question, could you have used the integral test?
Yeah.
Limit comparison, a little bit faster.
Alright, I did the integral test.
Yeah.
Do you have to, like, because it was like, it's kind of confusing, so do you have to write for all of it, since the limit as n approaches infinity, 1 over square root of n plus 3 equals 0, and then it's decreasing. And some absolute value, since a sub n.
You could just say it's divergent.
By the integral test?
There you go. From, and yours would just be by the integral test. And then your work could be up above.
But basically we have to, don't we have to like state that it was positive?
What I've been doing is I've been putting it like in parentheses, like P series, like for the easier ones, like P series, P is equal to a half or something like that. So for your integral test, you would do parentheses, like if you would do it the shortcut way, by the integral test, parentheses, absolute value base of n, continuous positive decreasing, comma, the integral diverges, therefore the series diverges. You can do that.
Okay.
So you could shortcut it in like a parenthesis. I've been not writing the full proofs in the parenthesis. I've been putting enough information to say that it's true.
Okay.
We'll talk a little bit more about your guys' justifications when you get back your quizzes. But I think you've grown. I hope you've grown. Anyway,
I know I didn't do the explanations correctly.
question. Let's work together on 8, 9, 10. I don't think we have too many. Is this the end? Ooh, we have piecewises? That'll be fun. Okay, pause. 8, what are we going to do?
Limit. No, integral test. Integral test, yes.
Whoa, integral, yeah.
Integral works.
It's easy, I'll let it
Good job, Noah.
Yeah.
Good job, Corey.
Thank you.
So does that mean that we're considering the absolute value first?
Yes.
So then, if we consider the absolute value, okay, what are we going to say? 1 over n ln of n, or we could do 1 over x ln of x, right? Is it continuous?
For the given bounds.
For the interval, yeah. Is it positive?
Yeah.
For the given bounds, yes. Is it decreasing? Yes.
So it's conditional.
What does it do?
It'll be ln x. That's a big one.
Yeah. Well, it's also.
B 0.2 to B.
No, to
So what am I going to answer?
B version.
So the absolute value of divergence.
Well, we basically know nothing.
Yay.
Now we know
It's a limit.
And,
the limit at the end of the infinity.
because remember one more time, if you find that the absolute value is divergent by anything other than the nth term test, all we know is that this is not absolutely convergent. But could it be conditionally or divergent? Yeah, so we have to check, right? But then as we check the limit as n goes to infinity of 1 over n ln of n, does that indeed equal 0? Yes. And as we already talked about, 1 over n ln of n is decreasing. Then the series is. So question, pause, 1 second. So does this alternating series converge?
Yes.
full resounding yes. Why? These two things are met. The alternating series converges. How does it converge? Conditionally based upon the fact that it's alternating. But does it converge? And everybody should say yes, right? Conditionally convergent, okay, Noah, you had a question first, go ahead.
Did we ever get backer test?
No,
No.
we need to. Begin right now.
You will, you'll not have a second.
Why do we choose to take the absolute value first?
They said so. And that's why I brought the point. I was like, so we know nothing. Well, we do know it's not absolute. So I was bringing up the point that if you do start with the absolute value, sometimes it diverges by nth term test, you're done. Sometimes it converges, so therefore the series is absolutely convergent, we're done. So sometimes it can be fast, just this one was, oh well, we still keep going. How about this guy?
You take it both.
Geometric.
Why would I say you should start with the absolute value on this one?
Because
It's geometric, therefore since the absolute value converges, the alternating series will converge. So we're done, right?
Yeah.
Well, actually,
Converges by geo series. R equals 1/2, right?
Yeah.
Miss D, you put n equals 2 instead of n equals 1.
Oh, thank you. I was on the list.
And then are we supposed to keep the negative 1 to the end in it? Or,
For the absolute
yeah, you know?
Yeah.
I mean, technically, if you're taking the absolute value, you could just say 1/2 to the n and leave off the negative 1.
No, but like, so I know for like the first ones usually we don't, when it's an opposite value, we don't.
Right, because the alternating series test says consider a sub n who is separate than your alternator, than the alternating sign.
Well, it converges to 1/2, but it's actually converged.
For those of you guys that are done, you can start thinking about number 10.
so are we considering just doing absolute value first if it requires, if it requires?
There are two different strategies. So remember, there are two different strategies. Sometimes starting with absolute value like this one is fastest. Sometimes it still requires a whole process. The reason that this one I would say definitely start with absolute value is because you can see it's geometric series convergent.
Wait, first one diverges.
All you need to do is the absolute value and then
Yeah, the second one diverges.
And if this was divergent, though, you still have to go check the other tests, so that's why I usually check or start with the nth-term test first. That's just me.
Because it's decreasing and it's 0.
Oh, yeah, it could become.
But long story short, you wouldn't be wrong if you started with something else than I did. Does that make sense? You'll still get it. It might take longer.
Or this,
Pause. Not many of us can just look at this and be like, yeah, I got it. Can we just start expanding? Okay. When n equals 1, what do I got?
2.
When n equals 2, what do I got?
Negative 1.
When n equals 3, what do I got?
1.
When n equals, I can't write. sorry.
Negative 1/2.
Negative 1/2.
We're on 1, 2, 3, 4, 5.
4/5. 2/3. 1/3. Negative 1/3.
5, 4.
But where's these negatives coming from?
Negative 2.
Pause. When n equals 1, it's in the odd camp, I gotta plug in. When n equals 2, it's in the even camp, I gotta plug in. When n is 3, it's in the odd camp, I gotta plug in. When n is 4, it's in the even camp, I gotta plug in.
I'm just, where are negatives coming in? What number?
Negative.
There's a negative.
Negative 2 over n. It's for all these.
So when n equals 1,
Oh. Oh, okay, that makes sense now. I didn't realize you were like switching equations.
yeah, piecewise, tricky, right?
Yeah, I like it. It's quick.
How do I think about this?
If you did it separately, you could say.
Is it a telescope series?
No.
But separately, if we get a convergent plus a convergent, we'd be all right. But if we get a divergent plus a divergent, we're in trouble. Or more specifically, a divergent minus a divergent, we're in trouble, which is what this would be.
Well, that would be 2/3. But is it a telescope?
We keep on going. What's gonna happen if we keep plugging in? N is 7,
Next one is 1/2.
we get 1/2. N is 8.
Negative
1/4.
1/4.
1/4.
And 1/3 when you cancel out.
Doesn't seem to quite be perfectly telescoping, but we could keep going as far as maybe seeing if it does telescope. For right now though, from what you can see, what can we say?
It looks like it's converted.
It's converted.
Oh.
I'm like 3-ish,
What's the struggle?
but no, 2-ish.
Don't say what it looks like. Give me reasons. Because remember, we've already talked about what it looks like doesn't always make sense in this one.
As n increases,
The terms, some of them might cancel out.
as n increases, the terms of a decreases.
How about the 1/2 and then 2/3?
Yeah.
Stop.
It is alternating, but the struggle is, can we say the terms are decreasing?
No, not fully.
It's like a sign.
Could we keep trying?
That becomes 1/6.
Maybe eventually.
So eventually.
Okay, so some of you are stuck on the eventually thing. Let's do a few more terms then. Help me out. When n equals 7, what do we got? 1/2. When n equals 8?
Negative 1/4.
-1/4.
Negative 1/4. Keep going. When n is 9?
4 to 2/5.
When n is 10?
Negative 1/5. 11 is
1/3.
1/3. 1/3 they cancel out.
Stop.
What's the next one? 12. 1/6. Say 1/6.
Okay, so we went further. Some of you realize the 1s cancel, some of you realize the 1/2s cancel, some of you realize the 1/3 cancel.
But in the 2/3.
I still don't know if it's exactly a strictly telescoping without us going a lot further, which is going to get to be a mess, right? All right. Is it alternating? Yes. Does it eventually start decreasing?
Yeah.
Actually,
Because it went from 1
Here's a struggle.
1/5, 1/3.
Here's a struggle.
1/5, 1/3.
Here's a struggle. Okay.
Not really.
Is there another way of looking at this without just saying alternating? Because right now, alternating, it's like stink, it doesn't seem to be matching up. We'll pause, hold on. Can't we say it fails the alternating series test?
Yeah.
What's the alternating series test say?
The limit has to be and terms have to be decreasing.
Oh, yeah. So.
But pause, the alternating series test says it diverges only if.
So you can't say either.
So what's true if that is true and this is false?
Fails
The test fails. Okay, well then, what on earth could we do?
This is the first.
New test.
A new test,
We don't need
an old test applied in a new way. I like what you guys were saying as far as telescoping. I'm just not sure you fully understood what was going on. What's 2 minus 1?
1.
What's 1 minus a half?
Oh,
1/2.
What's 2/3 minus a third? What's 2/4 minus a fourth? What's 2/5 minus a fifth?
just blew my mind.
It diverges by the nth term test, n is equal to 1, because what is an equivalent series to this mess that they gave me?
1 over n. Wait. 1 over n plus 1.
Since the series equals, n equals 1 to infinity of 1 over n, the series diverges by the p series. P equals 1. Now, what made us have to look elsewhere? Telescoping was not nicely working, number 1. Number 2, the alternating series test, the limit passed, but the decreasing failed. So then we had to say, all right, there's another way of looking at it. Was the telescoping idea good? Yes. Because telescoping says, hey, let's group stuff together. You guys just didn't realize exactly what we could do with that. Does that make sense? So can we say, just because the terms aren't decreasing from the alternating series test that it diverged? No, we couldn't say that. The test failed. We weren't sure what was going on. But once we see what it's equivalent to, then we say, oh, from another test, dun, dun, dun. Otherwise, if we hadn't been able to do that, we basically would have had to put we know nothing.
How would you know to put those numbers that you did together?
I'm not sure I can answer that one. But it's pretty spiffy that we got it to work.
So experience.
Experience, yeah.
Just less. Yeah.
But I was showing you how telescoping wasn't working nicely. Alternating series test basically told us nothing. So then go back to the telescoping idea, is what I'm showing you through this example, and see if maybe we can make it equivalent to something else. Long story short, a piecewise series is a mess, and if we can make it into a simpler series, we want to. So this is one way of taking a mess and seeing if we can make it equivalent, is by grouping the terms. First two, second two, third two.
I was like, oh, when these two combines together, is it still an alternating series? So it's just a random.
Because it's positive. And so this also showed us it's not telescoping, because it's not canceling everything out, it's continually expanding.
Okay.
Does that make sense? It was like telescoping, but wasn't working quite well enough. Katrina?
This problem is super complicated, but could you have done it this way where you like use like direct comparison between the two? So like
The problem is direct comparison doesn't let us deal with positives and negatives.
okay.
Does that make sense?
Yeah.
So we're gonna run up against maybe the magnitude of the numbers being higher or lower, but we can't.
Like say definitely.
Right. You guys wanna play with the next one then? Or the piecewise? Let me give you a second. And I would say expand it. Let me zoom in on it so you can see it a little better. I'm not saying it's the exact same, but expand it. See what you can do with it. My hint, expand it. Excuse me. Thank you.
I just did the first like 6. Yeah, I kind of grouped them. Yeah. Right out of 40.
They never come to.
Like one's divergent, one's convergent.
So it's divergent.
One is divergent, one is convergent now.
So what do you do?
You just say everything fails.
So what's the common ratio from 3 to 13? And 13 to 31?
I don't think there is one, Kyle, because 31's prime number.
They're all prime numbers on the top end.
Bottom one. What if 48 is 12? How many? What's 12 times 48?
10,000.
Okay, that's not it.
Too big of a number.
Well, you could just do 10 times 4 and then 8 times.
Geometrically, but it's not working. How you mark that?
Say that again.
How do you like your group?
144 times 4. What's next exercise? 7 and 8, so 1/7 is negative 164. What's 7.7? Something. There's no way to get 2 sevens.
It's like 500,
We need to do a different test.
Well, I'm trying to do that, but that's not working.
It's, yes.
I don't think you're gonna be able to get that.
Well, two, both?
No.
Series, all the bottom numbers for the odds are prime except for occasionally. Like 3, 5, 7, you can't get those to match.
One and the other.
Well, you have to do is you have to multiply them by 16 by 3.
Why not we, can't we use P-series for the?
What do we got? What's first term? Second term? Next term? Next term?
16, 1/5, negative 136.
Negative 164.
Yeah.
What have you guys tried so far?
We're not combining it.
First and second,
Didn't really-
and second and third.
Wait a minute.
Why not alternating series test?
that works. It's decreasing.
Why not alternating series test?
Never mind, it's not decreasing.
Oh, because it doesn't equal 0 and it's not decreasing.
Then it does equal 0, but it's not decreasing, right? Because we're going down and up and down and up and down, and that's not gonna work. Okay, so now, right now we're trying to combine things, right? So we had 3/4 for the first one, what's the next one?
1348.
13/48 is the next one?
31 over 180.
Okay, so we can see it decreasing, the problem is it's no longer alternating. Does anybody figure out an nth term formula that would match it? Oh, I'm just asking.
Yeah.
Bunch of prime numbers up on top, so that means that we won't be able to have an nth term expression for it. Okay, that's a bummer. You guys were just saying, how about the first and the third? Is that what you were saying?
Yeah, no, I did second and third, so like negative 1/4 and 1/3, but it still didn't do anything. It was, first it was 1.
So you're trying to separate the terms a little bit?
Yeah, then 11/80.
Okay, and that wasn't working either, still prime numbers, right?
Yeah.
Maybe you can round it.
1/3 is roughly 1/2. Yeah, maybe close to 1/16. It's like. They're all like roundings. I don't know. They're all.
Really, really heavy rounding.
Maybe it's
Very heavy rounding. Seriously heavy rounding.
Yeah, exactly.
Any other ideas?
Maybe it's converging.
Could we rewrite it as two separate series?
Yeah.
How would that work?
You'd have 1/3.
No, we wouldn't be able to do 1 over n.
Oh, wait.
What you mean?
Wouldn't it be, because we need 1 and then 3 and then 5 and then 7. We can't do 1 and 2 and 3.
N plus 1. N plus 1.
No?
Starting n equals 0, and then it's n plus 1.
N plus 2.
How about 2 and minus 1? Because then that'd be a 1 and then 2 would be 3 and then 3 would be, so that'd be one way. How would we make it the other one? Well, we could do minus, technically, couldn't we? Because all of these are going to be negative. What would the next one be?
2n squared. Wait, he's something squared. N plus 1.
Well, it's 4 to the 1, 4 to the 2, 4, oh, that doesn't work, right?
N squared. N plus
We could do
Start at 2.
n plus 1 squared?
1 over 2 is squared.
Because we have 2 squared, 4 squared, 6 squared, 8 squared. So 1 over,
Oh. This is how it works.
so 1
Yeah.
would be 1/4. That'd be the first, right? 2 would be
Yeah.
1/16, and then 3. Okay. I know this one is ultimately going to be convergent by p series, p equals 2, right? I know this one is diverges.
Or Louis
I mean, you can do integral or you can do limit comparison. I do limit comparison, 1 over n diverges, limits 1. Integral test takes too long.
That's only if it's easy.
Question. Divergent minus convergent, what do you guys think? If it was infinity minus infinity, I wouldn't know. If it was convergent minus convergent, I would know. If it was divergent minus divergent, I already said that one. If it was, what's another one? Convergent minus divergent? Divergent. Divergent minus convergent? Divergent.
If you're divergent, like
Here's the struggle. How do you actually write that one out?
Create a proof for it. Since that's
Try to create your own test.
Since it was like not working out.
like kind
We
of
made it divergent. It's divergent because we made it.
Nice thing is it wouldn't be on FRQ, it would be in multiple choice because you figure out that it's divergent. But you could go through and explain why this one is divergent, why this one is convergent, and then be like, oh, hey, divergent minus convergent will be divergent.
okay, when we think of divergent, we think of infinity. Anything minus infinity is always stronger.
Exactly. The divergent wins, basically. So we have to apply a lot of our previous math to get there. Does that make sense though, guys? As to why it's divergent?
So that's like a multiple choice question.
Yeah. Most of these are, to be honest.
You have to guess it out.
Let's not go through that right now, even though it's good.
Let's just keep going.
Wait, what time do we get out of the stove?
I actually have no idea.
I have a picture of it on my phone.
11:24.
Where are we at, number 22?
Oh my gosh.
Wait, what?
Yeah, 22.
Will we get out now?
Pretty soon.
We get out in 17 seconds.
Kyle. Kelly.
Those are the A's.
Noah.
Those are all the closer to the A's than that.
Yuki.
Are these
Gabby.
Never mind.
Let's go.
So when did we get a test back?
Wow.
Where did we go?
Here, you got Kyle already.
We get like points back for correction. We get points.
Long story short, I think you should be stronger now than you were before. So tonight, instead of finishing because we haven't gone over error, do corrections on your quizzes. Come tomorrow with questions that you don't know as to why you missed points or what the right answer should be. But I think you should be ready. Dylan, come on down. Should be in this quiz again and say what went wrong. Tom, Dylan. Bye guys, let's start corrections.